I'm Anil Kumar, and in this video we are going to check which are the indeterminate forms and where Lee Hospital's rule can be applied. We are given that limit for f of x when x approaches a is 0, limit when x approaches a for g of x is 0, limit when x approaches a for h of x is 1, limit when x approaches a for n of x is infinity, and limit when x approaches a for p of x is infinity. So we're given these 5 functions and their limit when x approaches a. Now the question is, which of the following limits are indeterminate forms? Second part of the question is, evaluate limit where possible, right? So these are 2 questions for you. You can pause the video, copy the question, answer, and then look into my suggestions. Now let's start analyzing them. When we say indeterminate form, we are looking for 0 over 0, or we are looking for plus minus infinity over infinity, right? This could be any combination. Okay, this is what we're looking for. So when I say limit x approaches a, we are given the limits are for these functions are 0, 0, 1, infinity, and infinity. For nx, the numerator, it will be approaching infinity, denominator f of x approaches 0, right? I'm just writing them down like this, and then we'll answer the question. For f of x, it is 0, and here n of x is infinity. In this particular case, n of x is infinity, and then we have infinity for p of x, h of x is 1, and n of x is infinity. Now, if you check, then we can clearly see that the indeterminate form is C, right? So that is infinity over infinity, right? So that is how we can answer the first part of the question. Now, for the second part, we are saying evaluate limit where possible. So if it is not indeterminate form, we can actually evaluate, right? Now, if I have nx over f of x, and we have a situation where as x approaches a, we could have, what kind of limit could we have in this particular example? This is what we have to think. And that is probably a very critical question. So I'll postpone this for some time, and let's answer these ones here. Now 0 over infinity, that means a large number. 0 over large number should be equal to 0. So the answer here is 0. Limit when x approaches a for f of x over n of x, where f of x approaches 0 will be 0. 0 divided by any large number, howsoever large it may be, you'll get 0. Here we are dividing 1 by infinity, which is also resulting into 0. Infinity is 1 over 0, right? So 1 divided by a large number will result into 0. So we get 0 in these 2 cases. This question, however, remains. Now here, it is interesting to note that we can get many combinations. Now let me take an example of a function to illustrate. So if I have n of x as equal to, let us say, 1 over x squared. Now limit of this as x approaches 0, so our a could be 0, right, is actually infinity, right? Is actually infinity. So it satisfies this condition. For the denominator, which is f of x, we could take a function which could be, let us say, x squared. Now limit when x approaches 0 will be what? If I write 0 here, it will be 0. So it satisfies this condition, right? Now if that is the case, what do we get? We get infinity as our answer, right? So in this case, it results into infinity. However, if I change this situation and I say my function is not x squared, but it is minus x squared, in that case, we may get minus infinity as our result, as you can see here, right? So in this case, it is possible to get either positive infinity or negative infinity as our answer, depending on the value of the function, right? So both are possible, right? So that is how we are not very certain about this part. Depending on this, so we can say it could be positive infinity or it could be negative infinity, as the case may be, right? So I hope that helps you to understand that in different scenarios where we have quotient of functions, when will it be an indeterminate form and when will be in a position to find the limit, as we did in this example. I hope that helps. I'm Anil Kumar. You can always share and subscribe my videos. Thank you and all the best.